So today I would like to take a class on helical gears. In fact, I hope it's audible, right? Hello, is it audible?
Yes, sir.
So I'm just taking the on helical gears, and here you can see this is the KTU syllabus as per this one, the fourth module, which comprises of helical gears, bevel gears, and worm gear. And today my topic of presentation is on theory and concepts of helical gear, design procedure of helical gear, and design problem demonstration. How we are not going in deep, and introduction to the bevel gear. So let's come to the helical gear here. So different type of gears already just covers per gear, helical gear, bevel gear, and worm gear. Out of which focus is more on helical gear. When we compare the helical gear with the spur gear, in fact, the spur gear knowledge is very important to learn about the helical gear because that have many similarities here when we design. So when we see that one helical gear will have a inclined teeth when compared to the spur gear. So use this pointer. So you can see the spur gear and the helical gear, which have much difference here in case of the teeth inclination with the axis. Now there is the next difference we can see here. That is according to the helix angle is changed here. This is a straight teeth and it's an inclined teeth. And helix angle is changed, and here also we can see there is a spiral teeth in the case of helix. Yes. Now the main idea behind the helical gear when compared to the spur gear is that it starts from a leading edge and it goes to the trailing edge. What I mean is that it's like there's a next video where we can just clearly see how it's moving. That is starting from a start point, then it moves to the end point. However, in the case of spur gears, all the teeth are directly in contact, and this can be viewed in this GIF image. We can see that you can see the teeth is going outside. First is in contact here, then it moved downwards. So here also it can be well seen that the teeth is coming in contact from the leading edge to the trailing edge in meantime. The major advantage of this one is that there will not be any noise. I don't say no noise, however, the noise is much less in the case when compared to the spur gear because there will be impacts happening in the spur gear. And here there is no impact of the teeth. So slight, very smooth movements happens in the helical gear. Now, this is a source from Bandari textbook, and the major nomenclature for this one is that it will take two planes. That are two planes is that one is the transverse plane, other one is a normal plane. So this is in fact showing the cut portion of the helical gear, and this is another cut portion of the helical gear where this is placed in a normal plane, that is almost some angle, at an angle psi with the horizontal. Yeah, I hope everyone can see this one. There is a psi angle with the horizontal here. So this plane, two planes are the XX plane and YY plane. So XX plane is that is on the screen board, on the screen itself. So it is resolved as psi. So there is a angle psi, and this is called angle of helix for using the in the calculations and design. But when compared to the normal plane, we can see this is alpha n. That is actually normal pressure angle, which is a pressure angle. We have seen the pressure angle in the case of spark gears, and the case of helical gears. There is two pressure angles. That is one in the normal plane, that is resolved in the normal plane, and there is in the transverse plane. So transverse plane, in fact, it is really like a horizontal, and the other one is having an inclination of psi. On that plane, it is taken. Now, helix angle can be exactly defined as, and you can see this part is actually the pitch circle. That is, the gear is kept parallel to the surface or the ground. So as a result, there is a pitch circle here, and we are defining a pitch circle here, and this is the axis of the gear. This is the axis of the gear, and now from the normal plane, actually we are just drawing a line at the center of the teeth, like this way. And when the axis of the teeth which combines or which coincide with the axis center line of the teeth, which forms an angle called helix angle. So some major nomenclature or terminologies of this one. helix angle, you can see that angle is taken with the horizontal. Next comes is this is another one called a formative gear. This is another concept here where we know the spur gear is well defined with all the equations and design. So the major thing is like this is the pitch circle. What we are doing is we are cutting with a plane that is at the angle of psi. That is the helix angle at the angle of psi. Now once it cut, it's in a circular form already. Now the circular form when cut, we can obtain a helix like this way. And from this helix with the radius r dash, if you are just drawing a circle, then we can obtain a spur gear like this. That is called a formative gear. In fact, there is no gear here, but it's the imaginary gear. So with the imaginary gear, all the calculations are based on this imaginary gear of the spur gear. So most of the design procedures are clearly same as that of the spur gear, except there is an angle that is psi. That makes the difference. So you can see this r dash is equal to d by 2 cos square psi. So in the case of a circle, it can be d by 2. But however, there is a cos square phi comes here. So always there is a cos phi that comes as the factor in the case of helix gear. Now helical gear tooth form. There are straight and spiral teeth. You can see in this one. So obviously, this shows a spiral one. Like this shows a spiral one, and this shows a straight one. These are straight like this. This way having a spiral, a different type of this one. Then depending upon the direction, they have divided into two, like right hand helix and left hand helix. So when see the right hand helix, so this is the major thing is we can identify a right hand helix with the hands which is keeping on this one. Or there is another way in the 2D method, that is when we draw from the lowest position to the highest position, then it is a right hand helix. Or from the highest position to lower position, then it is a left hand helix. So how can we determine this one is in fact always we are seeing whenever there's a 2D diagram, we are viewing from this point, not from this point, from this point. So this point lowest to highest. So this can be viewed with the help of a hands. By keeping hands like this way, this is the left hand. When keeping out the gear, what happens is that the thumb is pointing towards this one. And from here, it should elevate. It will elevate in the topmost position as we are drawing like this way. That is from, it should from lowest position to the largest position. So in this case, however, this is a right hand. However, when we keep the left hand, when the thumb is pointing towards the elevation position, we can assume that that is the left hand helix. And when we keep the right hand and when we point the thumb like this way, if elevating towards this one, this can be the right hand helix. However, whenever if there is teeth is coming in the downward direction, we cannot use that. Only the teeth should go in the upward direction whenever hands is kept, and we can determine which type of helix. And in this case, obviously, when keeping the left hand, you can see that it should move upward. And the case of this one also, it should move upward. That is towards this one. And we'll be viewing not this part here. That's an important factor here. And different other type of helical gear sets are helical gear, double helical, helical, closed helical, helical rack and pinion. Now, these are some of the figures which shows the normal helical gear, double helical gear, helical gear, then closed helical gear, rack. Then they're in the meshed format or mating format. Two gears are mated together each other and showing the weight. These are the types. However, this is not covering our syllabus. We're not going into that. Helical gear have something. However, just I'm dealing only with the helical gears. And there is another factor called the thrust, which comes into the action. So the thrust is like gear is on the shaft. It is trying to move away from the shaft, that is pushing out from the shaft. That is called the thrust. So that is a major disadvantage when compared to the spur gears to the helical gears is the thrust, axial thrust. And there should be ways to avoid this one or to reduce the thrust. So when we see the thrust, like is it time? Hello.
Yes, sir. Please continue, sir.
Okay. If there's a thrust here, in fact, what happens is that this will try to pull out from this one, the shaft, and this will try to pull out from this one. So this is a left hand helix, left helix, like a left hand helix shape. So what happens is the thrust will be towards this direction and this direction. And there is another method to find out this as well. And I'm just showing. functionality. So the major method is that this is a procedure to find out how the thrust acts. So total forces acting is tangential, radial, and a thrust force. That are the forces acting on the helical gear. And when we see like it's happening in rotation, suppose this is rotating in this direction, that is clockwise direction, and we are finding that whether the cell LH, this is a left helix here. So we are keeping towards the fingers are directing towards the rotation and just keep seeing the thumb direction. If it is towards this one, the thrust will be always towards. In case of a left-hander, it should be taken care that left hand should keep like this way in the pointing towards the axis of rotation and find the thrust. Similarly, when we see in the left hand towards, if the rotation is towards this one, that is anti-clockwise in this case, if I'm seeing from this side, then we're keeping towards the fingers like this way, the thrust is towards this. That means the gear will try to pull in this direction. So we should have some bearings at this point. In the case of right direction, again, if the rotation is in direction, we are keeping our fingers in the direction and seeing the thrust. Thrust is from here. That is, gear will be trying to push away from this one. And the case similarly, this one, thrust will be like this way. So once we find out the thrust for the rotation, that is rotation means it's a source, like it's the driver. Whenever it's a driver, we are just seeing only the driver. If this one thrust, this is the opposite to that. The other gears will always have a thrust opposite. So only thing we have to find out for the driver, the others can be easily find out. Now to resist this type of helical gears, the thrust in the helical gear, you use axial ball thrust bearings. So that will be connected here, and the next figure you can see. Whenever the thrust occurs, we'll be just loading a bearing. There is a thrust, we will loading a bearing here. That it will the motion, that is the axial motion of this gears to get out from this particular thing. And other cases, this shows only that there is a bearing can be the motion in the axial. Now, Helical gears are an answer to this question. Like what happens is that two gears are assumed to be on two sides, and one will form a thrust in this side, and one will form another thrust in this side. Both sides there will be thrust. As a result, it will cancel each other. That is Helical gears where the thrust can be avoided. Well, there is a one of the main advantages that there will be less vibration, noise will be less for this type of helical gears. However, the speed, in the case of speed, it is not much advisable for this one. In the case of this one, and speed reduction is not as good as for gears. Now we come to the design, and I hope the time is okay with that. This is my second point.
Yes, Jobin sir, I have received few questions in the chat window.
Okay.
So a few students want to know about the book which they should refer for the topic.
Yeah, as far as I have seen, as far as I have seen that most of the universities focusing more on the book called Raghavendra, although it is not mentioned there in their syllabus. However, many questions are just asking from this. However, the concept can be well cleared from book Bandari, the theory part also from Shikli. That will be better. But the problematic is better to concentrate on Raghavendra.
Okay, sir. I have received another question from Venkatesh. Do we need to know the direction of thrust force or axial force?
In fact, in some questions, if they're asking to find out the thrust force, the direction and in a geometrical way, or to just find out the free body diagram, or to draw the free body diagram as per Gandhari textbook, obviously we have to find out. However, it is not seen, but if asked means it is a necessary.
Okay, sir. The students are asking regarding the data book. Which data book should they refer?
So I have prepared this lecture based on Mahadevan, data book by Mahadevan. Also, any data book can be used as per given in the syllabus, like PSG, or PSG is a standard one. However, most of the students are following the Mahadevan, so I just followed the Mahadevan. And I think that is easier. Although it is easier, there are some mistakes in some parts, and it should be taken care. So Mahadevan is a colorful version of that book, and can be. I think many of will like that. And then right now the PSG also coming into that point of color.
Okay, sir. I have another question. Are these gearboxes made of herringbone gear?
Which gearboxes?
It seems it is a general question
Yeah,
regarding
it's
the
normal
herringbone.
gearboxes. Okay. Yeah, herringbone gears normally I don't see that it is. I haven't seen them in the gearboxes. It is, but however, either high-speed applications we can only go for is for gears, not for the herringbone gears, and it will for a noiseless operation. But however, I've seen that new advantage, like new technology advancements, use this type of herringbone gears, and helical gears mostly is seen. That is the best one in the gearbox. I hope so.
Okay, sir. I have received another question. Is the procedure for finding the thrust same for all gears?
Can you repeat the question?
Is the procedure for finding the thrust same for all gears?
Means I hope like the thrust for helical gears will have the thrust almost. So this method is applied to helical gears. However, the spur gears there is no a thrust does not happen here because total forces acting on a helical gear are like tangential force. Normally, that is also in the spur gears, and the radial force that's also in the spur gears. However, additional force called a thrust force because of the angle of helix that happens only in the helical gear. So this is the method for gears, not for any other.
Okay, sir. So Midun has asked a question regarding the same, sir, for the same gear in one direction, it will be left-hand gear, and on the other side, it is a right-hand gear. So how can we differentiate it?
Yeah, that's a good question here. I was thinking of that one. Well, so whenever we find the direction, the major thing is like from the lowest position to the highest position. We will only consider from the lowest position to the highest position. If we change the gear in the other side, the direction changes. That is from the top to bottom it is going. So I hope he may be understanding that one. Like whenever we see that, that is from the lowest position to the highest position in the gears we see. But when we go for the 2D diagrams, always from the right hand side, like when we see opposite to the book, right hand side, we'll be considering to view how the gears is. So if the screen is visible means I can show that this one like from left to higher position, low position to higher position, we will always determine the gear direction, not in the other direction. So always choose that direction and find the thrust from that direction.
Okay, sir. So we can continue with the next session of 20 minutes lecture.
So next part is like I'm just introducing the design procedure of helical gear. So it is as similar as that of spur gears, except some equations difference here. And there is I told there is a psi, that is helix angle is added into this one. So a cos-psi factor will be always coming into being when we take the case of helical gears. So first part is like the steps are like this. Select the suitable material if not given from the table 12.7. So I said this is a Mahadevan data book I am following here. So from table 12.7, page 234. So we can take the material. If the PSU obviously material can be taken for the gears from the particular table. Now, the first and foremost thing is identifying the weaker part. Always we will be just finding the weaker gear because if you are making the weaker gear better, obviously the stronger gear will be much better than this one. So always the design is based on weaker gear. Otherwise, the suppose the pinion may be weaker or gear may be weaker. So if you take the pinion as a weaker one, and if you are just designing and making it to the safe condition, the pinion will never fail. Gear will never fail because already it is stronger one. So the first step is like if the material used for the both pinion and gear is same, then the pinion is considered as weaker. So if suppose the steel is used for making gear as well as pinion, then obviously we say that pinion is weaker, not the gear one. If the material used for the both pinion and the gear are different, then the strength factor sigma dy is used to determine the weaker part. So there are procedures. Then next comes is the design is based on weaker part. That is, we are We are just totally designing we are finding the weaker, then we are starting the design on weaker form. Step 2, that is, we have to find the module. So the major idea of finding the module is that when we are going for meshing, only two gears will mesh only if the modules are same. So obviously, if you want to design that one, we should know the module. That is important. So the first and foremost thing is finding the module in the case of designing gear as a step 2. So if pitch diameter is known, so there are equations that is given in the Mahadevan, that is, I have just referred the page number for the equation, that is module Mn, where we are using the N asked for helical gear. However, in the case of spur gears, the equation is different. However, the module is represented by N, where N. So in this case, Mn is about the normal. We are taking this since it is inclined state. We are taking module as normal module. Mn is equal to, and all the calculations are based on Mn, not on M. And from this one, we will find out, and the pitch diameter is unknown. Then the equation is changed. We'll use a different equation. You can refer the data book to see these equations. Then check for sigma d in the both cases. That is the static stress we have to find. Sorry, dynamic stress we have to find out in the case when it's in a rotating case. And the case is that dynamic stress is greater than permissible value design phase. The permissible value is the stress already given maybe in the question. Mostly in the question, that stress will be given. That is, maximum stress the gear can handle is up to this one Newton per millimeter square. Then sigma d, calculated sigma d should be greater than that one. Then the design will fail. That is, the design stress should be less than always the permissible stress. That is the condition. So, sigma d always greater than permissible value means design fails. Hence, adopter change the module and repeat from the third line. That is, I mean, like we have to just change from the change the module and restart from this one. Again, check this equation until sigma d less than permissible value, and you should have some factor of safety for long runnings. Then step 3 comes the find dynamic load on gear 2. So those who have learned the spur gear, they know that the procedure is same as this one. Also in the spur gears also we are following the same. Find the dynamic load on the gear 2, that is FD. So calculate the dynamic load, that is using the equation. Then comes the endurance limit. So in the case endurance limit, how long this gear have the life. You want to calculate the life. Only cases when question asks for finding the life of the gears, we are to go for this steps. Otherwise, it is not important. And the other condition here is that F endurance should be greater than FD. This dynamic force and endurance force should be greater than dynamic force, because only the long term years it can work. Then comes the limiting load for gear, that is wear. So wear may happen if the load is higher. When the load is above extent, then the wear may happen and the life will get reduced. So there should be load should be limited so that the wear does not happen. That is the idea of finding step 5. And for safe design, that is wear load, therefore should be greater than dynamic force. So what I want to say is the major idea here is that whenever gear is designed, the teeth are doing its work. Teeth are doing its purpose. So when the teeth should be strong enough to stand. So all the things we are calculating here for the teeth. We can see that module is for meshing. When comes the find dynamic load on the gear 2. So what is the load comes on the gear 2? In case of spur gears, there is a cantilever beam, and as a result, it can break. In this case also, there is a chance for that one, since it's also a cantilever. However, it's not in the each point, not like the spur gears. It starts from a leading edge and it goes to a trailing edge in the case of hills. And when we see in the other one, endurance links, how long it can hold, that is important. Then comes to the limiting load of for gear. Wear. So wear should not happen because of material wear happens. What happens? Again, the teeth is getting big. So all these things are doing to strengthen the teeth. Now, if FW less than FD, then equate FW equal to FD. That means at least wear load should be equal to dynamic load. The condition is wear load should be greater than dynamic load, but if it is less than, try to equate this one. Now, from that, FW is equal, these are the equations you can get from the data book here. Then find the value of K and choose suitable hardness for the gear and using table. So we are equating this one. We assume that wear load is equal to dynamic load and hardness of the gear we are choosing from the table, and then assigning, so that we assume that it will go for a long time, although this condition is not met. So not if in the problem diameter is known and C is unknown, calculate M assuming suitable values of C after obtaining M. Find the value of C again. That means if you are already, we will assume initially the value of M for calculating the other things, and then redesign. We are iterating, different type of iterations are doing, and finally we check whether the strength is greater than or less than permissible stress. So that is, if it's greater than, obviously we have to reiterate. If it's less than, we don't want to reiterate. And this is the design procedure. I think I can complete. I'm not going to complete. However, I'll just do some part of problem, just show that to understand the concept. So these are the references I have made to make the materials. So this is an example of question example I have taken from the Raghavendra book. So this is a pair of helical gears are to transmit. So major thing is that we have to design a helical gear. That is the idea behind here. So you can see the question. Like the gear has a pitch diameter, the gears are made of cast in allowable strength of under, determine the module and phase width from the static strength construction, and check the gears for wear, that is FW. You can calculate what is FW. So I have only completed up to module and their like phase width, and so here we can just try to solve this one. Like power is given as 15 kilowatts, that is transmit power, required power to transmit 15 kilowatt. And angle, stub angle, that is that we say the pressure angle is 20 degrees, stub in diametrical plane. Her helix angle is 45 degree. Then pinion speed N1 equal to 10,000 RPM. So pinion speed is given. Here the major thing is pitch diameter of the pinion is given. Also pitch diameter of the gear is given. That's I already told that if the diameters are given, we have to select a different equation, or else we have to do another one. So this here both the diameters are given for the pitch, for the pinion as well as the gear, and sigma d1 equal to sigma d, the static stress is given as 100 megapascal for both pinion as well as the gear. Then sigma es equal to 680 megapascal. So that is for a virtual gear we are taking the stress. Now just the procedures are like identify the weak part of the pinion out here. So here, since the material is given, and if they are not two different materials, so it's cast steel heavy, so we consider the pinion as the weaker one. Then we find first module, then find the phase width, then dynamic tooth load, and dynamic, so it's not tooth, it's a wear load. This is the procedure. So we have to go to the solution part here. So this is the solution part where I have just taken the photos of the data book. And the first and foremost thing is we will be finding I. Since here the major idea behind this one is we are assuming the number of teeth as not given. We are assuming the number of teeth. And first the preliminary procedure is like we will find out the gear as well as on the pinion. That is, we assume that Z1 equal to, because we are taking on the pinion case, Z1 equal to 20 teeth and Z2 equal to 80 teeth. That is on pinion and the gear. Now, second is the virtual number of teeth, where you can find out the virtual number of teeth in the page number 211, that is 12.228. There's an equation for the helical gear, Z by cos cube beta. From this, you can calculate Z. And gear ratio can be calculated by N1 by N2 equal to D2 by D1 equal to Z2 by Z1. But we know the D variable. So we can find out D2 by D1 equal to I. So using I, further we can find out the other teeth answers. So first and foremost thing here is that we have to find out So we have find out the parameters here, like it's the D, everything. Next one, as the first the material selection was the material was already saved, as a result we have taken. The second case is we have to find out which one is the weaker gear. So here it is found out pinion. Then we have to go to find the module. So when we go to find the module, we have to find out what is the equation of the module, and depend on the equation of the module, we will be finding all the factors. So here you can see I have represented as one here, the pointer. Represented as one here. This is FTCW by sigma D CV K Y, the odd power 1 by 2. So we have to identify all the factors in this one to find the module. So in this case, first we have to go. We have to go to the part that is all things are CV is given. CV is that for precision gears with the velocity greater than 20 meter per second. So the velocity is greater than this one. So we have taken this equation from 12.25. Then we go to 3. So this is what I've said. We have used the same thing. Then we come to FT. We have to calculate the FT. So this is another page 205 and equation number 12.78, where you are finding what is FT. FT equal to 1000 PCS by P, where CS is a factor which we have to choose from the table. And once we find FT, find FT using V and CS and P, where P is the power in kilowatt, that should be taken care, because many will be 15 kilowatt if given, should not be changed to 15 into 1000. Rather, we have to use the 15 itself. Then another variable is, you can see y is equal to, there is a equal to y factor you can see. So y is equal to, we already have form factor, y is equal to pi into y, where small y can be found out, the Lewis form factor can be found out from this one. Since the 20-degree pressure angle, so we can use this equation and finally we can find. So all the variables, like we have found FT, like CV, Y, then there comes another variable called K. So K equal to B by Mn, where we will be assuming this B by Mn as 15. Normally we have seen that assumptions we are taking is 15. If that is wrong, that is not a problem. We can again iterate and correct. So 15 is, for example, we have taken. Then it comes another unknown variables comes is CW, where we can choose the CW. Then unknown variable comes is sigma T, where we have to calculate sigma T. So the first things we are completed this page, and we come to next is so I have seen that CW can be find out from this page number 241. And this one is a table 12.21, where CW is there, where enclosed gear continuously lubricated with oil of proper viscosity and character, because nothing is given specifically. So we have chosen this one as 1.15. Then that's I told, assume B by Mn is taken as 50. And another one is recommended modules, that is we have to calculate the module. We are calculating actually the module here. Using all the equations, we are calculating the module. And once the module is calculated, we will get a particular value. That is here somewhat 1.09 is getting above 1, so that we are choosing 1.25 here. So this is the calculations I have shown here. I think I have already shown. And so once the module is calculated, all the module is calculated, and you can see sigma D can be, you know, all the factors you can find out from this part itself. That is 240 page number, all the factors they have given the table. Okay, there's no need to remember all these things. Just see here, all the reference are being given. You can go and take the sigma D, CW, Y, this factor, K, B, all the things we can choose from this one. Once we find the module, the first step is finished, and we will standardize the module to 1.25. This is only the standardized means we will only get such gears in the, or can be manufactured such gears in the industries, which is a standardized form. Then once we find this one module, one head is finished, then we have to go for phase width. We have to find out the phase width. Now phase width equal to, we will get the equation for this one, that is equal to, this is a virtual number of teeth. virtual number of teeth, I told you there is a formative gear, so that we are forming a spur gear. From that, we are calculating the virtual number of teeth. So that can be calculated from this equation here. Then we have to go for base width. That is face width we have to calculate, and it is given us 15 times Nn, because already we have taken 15 as already we have assumed it. That is by okay, we have taken b by mn equal to 15. From this, we can take b equal to 15 mm. Module is already calculated from the previous equation. We calculate the face width. Then what the next thing is that face width is compared with the equation in the 213 here. Now face width comparing, so that the minimum face width is calculated as 6.38, but already we have face width of 90. Already calculation has 90. That is p by mn is equal to 15. From that we have 90. So p calculated, since p is greater than 19 is greater than 6.38, the calculated value of p is 6. So next one is to calculate Ft. That is tangential force, which is having an equation here. Then y is equal, again this was already calculated, and the major idea behind is that one we are just calculating dynamic force. So this has to be, that means stress we have to calculate. Now this sigma d1 is calculated, and we are comparing with the values already given in the question. 100 megapascal is the maximum that can sustain. So we are comparing, and we are understanding that 71.28 is less than 100. So it is again safe. So it gives the green signal, we can move. So that's all. Again, we have to go for the dynamic as well as the wear. So I have a bevel gear session also, that is already an introduction, and the further will be continued in the later classes. And so is it time up, or can I continue for bevel gear for at least some time?
So let's move on to the Q&A session.
Yeah.
Okay, we have few questions here. First one, how do we determine CV if velocity is unknown?
So velocity, yeah, obviously, you can see this. There is a term different. And if velocity, obviously there is a equation called pi d n by 60. You'll be using that one. But from this one, we can find out the velocity. Once the velocity is found out, we'll be incorporating in this one. We'll find out the CV. I think I have missed a step somewhere. Velocity is not found.
Okay, so the next question is, what about the velocity ratio of helical gear? Is it constant or varying?
Velocity ratio cannot be always varying, because velocity ratio, in fact, what is that means that the ratio of the output to the input, or the gear to the pinion. So we are reducing actually the velocity ratio. So it cannot be vary always. It can be always constant. Because in the case, I don't think that there is a way to like only reduction ratios are seen the velocity, not any variation happens. And in such a case of variation happens, it's very difficult if you're using in a gearbox in vehicle. But the problem is that when you have some speed, and without your knowledge, the speed will be getting increased, or the ratio is changing. That is uncontrollable.
Next, we have another question. While designing the gear, should we also consider the loading on the shaft?
Should consider the bearing.
It's given as loading on the shaft.
Okay. Should we consider the load on the shaft? No. In fact, here that there is a separate section for, as I understood, I'm telling, like there's a separate section for shaft design. So here, this is totally concentrated on only the gears, not on the shaft. Where shaft should be separately designed and the gear should be separately designed. I told you the design of the gear comprises of the design of actually the teeth. The teeth should not bend, wear, or it should not fail. That is a major idea here, not the shaft. The load will be obviously transferred to the shaft, and it should be designed in a different context.
Okay, the next question is the design procedure for helical and bevel gear same as spur gear?
No, no. The same procedure. In fact, the procedure is like to find the module, find the next stages, phase width, and where all the things will be same. But the bevel gear having a difference. Obviously, they have in equations they have difference. But as per the we say in words, that will be almost same, but not exact. That I hope I can cover in the next classes for bevel and bevel gears. How it happens.
Okay, sir. Another question is how to find the phase width for helical?
Yeah, phase width is that I have shown that phase width calculations. That that's why we are taken like there is a ratio already taken B by Mn, where B is the phase width, B by Mn equal to 15. This is the assumption. Once we come to the module case, we can find B equal to 15 into Mn. We have found out B equal to 15 into Mn, and we are comparing this phase width with 90 also with the minimum phase width requirement. We are calculating the minimum phase width requirement here. So we are comparing minimum phase width requirement. There's a module term for this module. What is the minimum phase width? Phase width. That is comparing with the already calculated or assumed phase width. Now B is greater than B minimum, so it's safe. So we can calculate.
Okay. Now there is a general question regarding the textbook for reference. Is the textbook named Machine Designed by Kurumi and Gupta enough for reference?
Yeah, obviously, what I have understood, from valuation process as well as teaching all the things, and then the university case, what I understand that the university expecting that we should have a knowledge from the theory part as well as the design part. Both part it should have a knowledge. So they will be asking the question which is split into numerical problems as well as the theory problem. And in that perspective, when we see that some textbooks are very good towards the design problems and some towards more theoretical concepts. Both should be developed. So I think the mixture of textbook always help. Obviously, Kurmi can help, but the nature of the questions that we're asking in the question paper, that the student should train in such a manner that they can face the exams with the expected type of questions, rather than going into wide area of different. In Bandari, I have seen the different direction of question. However, the university character should also be followed to train yourself to get a good marks.
So two more questions. If helix angle is not provided in question, do we have to assume?
Yeah, obviously in the design that is usually we are assuming all the angles required. So there are tables that you can assume some angles and can find. And the whole idea of the design is that one, we assume something, and finally we see there will be the question, they will be giving some stress, dynamic stress or static stress, and we will calculate our stress with the assumption, and we compare with the stress. If the calculated stress is less than the provided, that is permissible stress as given in the question, then the design is safe and is correct. It's no problem. So all the assumptions, with the assumptions, and when you go to the iteration, always the given permissible values or the calculator value should be always less than the permissible values that is given in the question. That's the whole idea.
Okay, sir, that were the relevant questions from the Q&A session. The rest of the questions will be answered and the answers will be uploaded in the website. As for now, sir, can you please summarize the session so that the student will get the gist of the content?
Can you repeat?
Can you please summarize the entire session so that we can wind up the session?
Okay. So, I just come to this point. Another thing. So what I have just presented here is first I have just explained the theory and concepts of helical gear. So as part of this one, helical gear, when compared to the spur gear, what is that the teeth is inclined to the axis. That is a major difference here. And the spur gear, it is parallel. So as a result of this one, there are advantages or disadvantages. The major advantage is that one, the noise will be less, vibration will be less. That is, smoother operations can be obtained as we are getting in the gearboxes, obviously in the vehicles. But in the case of spur gears, there is impact forces and the noise will be higher. And when we come for the high-speed operations, spur gears cannot be used, or cannot be, I don't say cannot be used, however, that is quite noisy and the